All right, so let me start like this. I'm going to go ahead and I'm going to start with the Pythagorean theorem. So let's begin like this. Pythagorean theorem, just to get everybody on the same page. Basically says this. If you have a right triangle, so if you have a right triangle, then a squared plus b squared is equal to c squared, where a, b represent the legs, and c is the hypotenuse. So what does this really mean? Well, what this really means is that if I start with a triangle like this, if I start with a triangle like this, and I say to you, this is a right triangle, then I'll call this A, B, C. I'm going to say that these are the legs, and I'm going to say that this is the hypotenuse. So what I'm suggesting is that if I have a triangle that is a right triangle, then this is true. A squared plus b squared equals c squared is true. Para traducir básicamente todo lo que dice aquí, es que si tengo un triángulo y yo sé de que es un triángulo con ángulo recto, automáticamente tener este tipo de triángulo quiere decir de que esta fórmula es verdad. Esto me da esto. Al tener este tipo de triángulo, tengo este tipo de cosas. So it's very straightforward. As long as I have a right triangle, then it's guaranteed that this formula is going to be true. I don't have to guess about it. I don't have to ask nobody. It's just automatically is true. This is the original Pythagorean theorem. The crazy thing is that today I want to do this backwards, if that makes sense. Because when I use the word converse, converse is not or shoes. Converse in this case means that I want to read it backwards. Okay? So by a show of hands, and I know some of you might be a little bit behind. Who needs more time? ¿Alguien necesita más tiempo? A los que me están comprobando o me están tratando de usar la tableta, toma un poco más de tiempo porque se están acostumbrando. Sí. Y eso es lo que quiero saber para los que se les hace un poco difícil, que me digan cuál fue lo difícil o cuál fue lo fácil. So if it's a little bit difficult, you'll let me know at the end. If it's relatively simple, then it's not a problem. Okay? All right. Do you guys have the definition already? You good with this part? So I'm going to move it so that I can at least see the picture, then I'm going to move it past this. All right. So I'm going to move this around there. Okay? And then what I'm going to do is that now I'm going to use something called the converse. So converse of Pythagorean theorem. Think of the word converse as just backwards. Because my original statement says begin with the triangle, this makes the formula. And all I'm really going to do when I say the converse is I'm going to start with the formula and I'm going to say if this is true, then that makes this triangle. So it's backwards. Okay? So we now say this. If a squared plus b squared equals c squared, then you have a right triangle. And that's all it's saying. So tenemos la misma información, pero al revés. Basically backwards. Okay? So, next piece. If I continue with this now, this basically is going to tell me, and for those of you just coming in on your notebooks, literally start with this. This is the main piece we're going to do anyways. So take out your notebooks, and that's the one I want you to start talking. Okay, so then can you try to take out some paper at least? Right now, because of what I'm doing, it can be regular paper. So here I'm going to say, if a squared plus b squared equals c squared, then the triangle has to be true. Al tener esta fórmula, si esta fórmula funciona, el triángulo tiene que ser con ángulo recto. You have no choice. The first one said you are starting with a right triangle, therefore the formula works. The converse says, well, you have the formula, and if the formula works, then this has to be a right triangle. That's all it says. Así que tenemos la misma información, pero al revés. So the key word today is this one that I'm calling converse. And that would be converse. Let's see if it picks it up correctly. A lo contrario, no es converse. All right. So now let's start with a quick example. Go this way. And I'm going to say as an example, A, B, C, and I'm going to say A equals 3, B equals 4, C equals 5. So there's no picture. It's just A is 3, B is 4, C is 5. So I'm going to use this and see what we have. So all that means here, I rewrite it here as A squared plus B squared equals C squared. A is 3, 3 squared. B is 4, 4 squared. C is 5. 5. And the thing about this is that there's no picture. I don't have to have a picture. I just have to know the math. So now I'm going to say, anybody call it out? What is 3 to the second power? 4 to the second power.
16.
16. And 5 to the second power.
25.
25. So how much is 9 plus 16 together? So 9 más 16, 25. Y a este lado ya tengo 25. So because this is the same number, automatically, then according to this idea, what's going to be my conclusion?
That's true.
It has to be what kind of triangle?
Right triangle.
Okay? Ya que esto coincide, y esto es en lo que me enfoco. I basically am concentrating on that. Because they are equal, I can now say this is a right triangle. So this is a right triangle. It works, so it must be a right triangle. Okay. Now, here's the thing. Not only does this tell me when it works, it also tells me when it doesn't work. So I'm going to do a different example. I am going to give you a triangle that I know on purpose does not work. And instead of being a right triangle, I'm going to purposely give you a triangle that is an acute triangle. Okay? So take a look. Is there anybody still copying this piece? The top piece with the picture? All right. You got the picture? I'm going to go this way, that far. So now I'm going to tell you, on purpose, I am going to create an equilateral triangle on purpose. I'm going to say I have an equilateral triangle. So this is going to be an equilateral triangle, which is also acute. What does acute mean? Yes.
It's like less than 45 degrees.
Close is actually less than another degree. 9. So 45 makes it acute, but it has to be because it's less than 9. Okay? So acute, which means less than 90 degrees. Así que voy a hacer un triángulo donde yo sé que a propósito esto no va a funcionar. And I'm going to say that this measures 5, this measures 5, and this measures 5. I know it's going to fail, but I want to see what happens when it does. So in here, A equals, I'll say this equals B, and I'll say this equals C. Since it's the same number, it doesn't matter what. Okay? Y solamente quiero ver qué es lo que ocurre cuando a propósito hago un triángulo que yo sé no tiene el ángulo 90. Right? I know it doesn't do it. But I'm going to start A squared plus B squared equals C squared. A is 5, B is 5, C is 5. So 5 squared, 5 squared, and 5 squared. I chose 5 because 5 is easy. In other words, what makes 5 squared? How much is 5 squared? 25. So 5 squared, 25, plus 25 equals 25. Lo mismo para todos. Now I'm going to add, and so this makes 50 equals 25. But then I realize this is not true. 50, of course, is ridiculous to say 50 is the same as 25. So instead what we do is we do like this. And we're basically saying it is not true. So this is going to be conclusion 1. But if I say that 50 is not the same as 25, what else is true? Like, what's a different way of saying kind of the same thing? How do they compare? How does 50 compare to 25, size-wise? But they're not equal, so what can I say instead? It's twice as big, right? But as soon as I make that idea, then I can say that 50 is bigger. Even if I don't count how much bigger, I can say 50 is bigger than 25. Así que este es más grande que este. So here, I'm going to make conclusion number 2. 50 is bigger than 25. Now the cool thing about bigger than is that then I can come over here and I can say 50 is bigger than 25. Larger than, bigger than, greater than. I can use all those words and they mean the same thing. But where did 50 come from? Well, 50 came from this part. So here's the thing. 50 came from a squared plus b squared. That's where the 50 came from. 25 was the other side. So 25 is c squared. So all of a sudden, in this situation, a squared plus b squared is greater than c squared. And now here's the problem. If it's greater than, because it's not equals, what kind of triangle did we have? I purposely told you the kind of triangle we're going to use. So what kind of triangle do we have? We have an acute triangle. So whenever this says greater than, we now say that we don't have a right triangle, we have an acute triangle. So in here, we now say we have an acute triangle because it's greater than. So I'll say this is number 1. Here I'll put number 2. When I have a squared plus b squared equals c squared, this is going to be a right triangle. If I then say a squared plus b squared And now instead of greater than, equal to, I now go like this. I have an acute triangle. I have a right triangle. Anybody know another kind of triangle? There are acute triangle, less than, equals to 90, and excellent. I heard it already?
Obtuse.
Obtuse. So now I'm going to say we have an obtuse triangle. And just to clarify what everything means, acute less than 90, a right triangle equals 90, obtuse triangle greater than 90. Esta es la conclusión que quiero tener. 3 partes. Un triángulo agudo, un triángulo igual a 90 y un triángulo donde el ángulo es obtuso. These are the 3 types of triangles you can have. I'm not worried about numbers or measurements. It's just these are 3 common triangles you can have. Okay? Questions? All right. Last thing I want to talk about today with you guys is basically this. If I give you 3 random numbers, will you automatically make a triangle out of it? Can you make a triangle based on 3 random lengths? Para hacer un triángulo, lo puedo hacer usando 3 números arbitrarios. So, here's the question I want to ask. Can you create a triangle with any 3 lengths? Is it possible to make a triangle with any 3 lengths? And actually, I would ask you guys to look it up on your phone. You can ask Google, you can ask Alexa, you can ask Bixby, you can ask, I don't know, whoever else is part of the telephone. Is this possible? Can I just give you 3 numbers and say, that's a triangle? ¿Se me permite hacer un triángulo con 3 números arbitrarios? Si yo digo, este mide tanto, tanto y tanto, ya estuvo. It's a guarantee. And the ones I want you to check, I'm going to ask you to check this one, see if this one is a triangle. I'll say A, B, C, just so that I know. And I'm going to say, let this one be 5, 12, and 13. Now, by the way, C is the biggest number, just so that we have something to look forward to. The other example is going to be on purpose 2, 2, 6. And this is A, B, and C. C is 6. Which of those 2 is a triangle? Both of them? One of them? None of them? Which one is a triangle? Take about 2 minutes. See if you can come up with something. You can look it up on your phone. You can talk about it with your partner. You can look it up on the computer, those of you who have the computer. Which one of those is a triangle? And you can ask on your phone, or you can type it on your computer, whichever one is easier for you. Anybody discover if either one of them is a triangle? Is either one of those a triangle? Is either one of these a triangle? Anybody know? So I'm going to show you something real quick and see if this makes any sense to you. Anybody discover which one it might be? Are either one of these a triangle? Which one would work? Which one would not work? Will both of them work? Only one of them? Anybody find it? So let me ask like this. Please look my way. Let's say this is the biggest letter, the biggest number, like 6 or 13. Let's say this is the biggest one. And then I connect A and B on every corner. So A is on one side, B is on the other. Now, picture it like this. If I have these extra pieces, what has to happen for them to meet? And will every piece actually meet? Questions, ideas? So I'm going to attempt to show you something, see how you guys deal with it. Let's see if it makes some sense. I'm going to look at this one, and I'm going to draw 13. So I'm going to draw it like this. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And this is C equals 13. A is 5. So 1, 2, 3, 4, 5. So this is A equals 5. And then up here, I'm going to say that this one is 12. So B equals 12. Now look at how those lines are arranged and decide whether or not I can put them on the corners and whether or not that's going to make a triangle. Then think about the second one. The second one The second one basically says this. C is 6. So I'm going to put it here, or one, two, three, 4, 5, 6. C equals 6. A is 2. 1, 2. And B is also 2. Which of those two pictures is more likely to make a triangle? Picture number 1 or picture number 2? Now think about it. This one is going to join right here in the corner. This one's going to join right here in the corner. Is this one ever going to touch? Because if it's this big and these are the same size, but they're short, am I ever going to make them touch? But this one is almost the same size, and one is definitely bigger. So one is like this, the other one. So I got one right here, and when I put them, they overlap, right? So if they overlap, can I move them to make a triangle? So this will make a triangle, but this one is too short. It will never touch. So even if I put them on the corners, I'm not going to bend this. I can't. So I can't make a triangle. So this is a triangle. This is not. So we say that this one makes a triangle. And we say that this one does not. Here the pieces overlap. Over there, they don't overlap. It's basically one of those situations. Okay? So listen carefully. That's the basic notes I wanted to share with you today. We're going to be practicing